I am back. So this is a quick tutorial explaining how to work out a couple of the problems from the method of differences worksheet. The first four problems in that worksheet use the method of differences, and it's based on your knowledge of partial fractions. So the first four problems are no issue, should be no issue whatsoever. We've done at least one example. The fourth one, by the way, of the lot, where you have the sum from r equal 1 to n of r upon 2r minus 1 times 2r plus 1 times 2r plus 3. This is an interesting one. I'm not going to work it out in full, but I'm just going to give you a couple of pointers. When you get your partial fractions, I think from memory, it's 1/16 times whatever the first partial fraction is, 1 upon 2r minus 1, and then plus 2/16 into 1 upon 2r plus 1, and then minus, here's the famous minus, 3/16 into 1 upon 2r plus 3. You're supposed to look at what's common in all three sets of brackets when you open out the sums. And if you think about it, 1/16, let's say, let alpha be the common portion, for lack of a better word, in all three summations. And if you think about it, the first bracket, just for the part that's common, first bracket would be 1/16 times alpha. Second bracket would be plus 2/16 times alpha. And the third bracket would be minus 3/16 times alpha. All that stuff will cancel out, leaving you with an expression that you can simplify rather easily. So this is number 4 from the worksheet. You do most of the work on that. You should be good enough at your partial fractions to be able to get it into that format. I want to take a look at number 6 on that worksheet, which starts as follows. They said if f of x is equal to 1 upon r into r plus 1, simplify, not f of x, what am I saying? If f of r, sure. If f of r simplify f of r plus 1 minus f of r. Now that's interesting, because if the expression for f of r is 1 upon r into r plus 1, then to get the expression for f of r plus 1, you simply replace r with r plus 1 wherever you see r. So f of r plus 1 should be an expression like 1 over r plus 1 into r plus 2. And if they want you to simplify this, f of r plus 1 minus f of r simplifies to well, can be written as 1 upon r plus 1 times r plus 2 minus 1 upon r into r plus 1. If we're looking for a common LCM, that should be r into r plus 1 into r plus 2. And in my numerator, I'll get, let me see, these two cancel, so you get r minus into r plus 2. So f of r plus 1 minus f of r simplifies to 2 upon r into r plus 1 into r plus 2. Right? Which was actually the one upon r plus 1 into r plus 2 minus 1 upon r into r plus 1. Okay, so that part is done. Hence, find the sum. Hence, find the sum from r equal 1 to n of 1 upon r into r plus 1 into r plus 2. Okay, now if we keep in mind, let's focus on this portion here. If I were to divide both sides by 2, I'll get a half into f of r plus 1 minus minus f of r is equal to 1 upon r into r plus 1 into r plus 2. So for me to sum this right-hand side is the same as summing this left-hand side. So let's see how that goes. The sum from r equal 1 to n of 1 upon r into r plus 1 into r plus 2 can be written as a half into the sum of f of r plus 1 minus the sum, that's of course from r equal 1 to n, sum from r equal 1 to n of f of r. Now I don't necessarily have to put the expressions in for f of r plus 1 and f of r. I can work with that as it is. So therefore the sum from r equal 1 to n of 1 upon r into r plus 1 into r plus 2 is equal to a half into, and on the inside there, I'll expand the first few terms to the first bracket. That'll be f of 2 plus f of 3 plus second to last term would be f of n minus 1, and the last term would be f of n. All of that minus what you get when you plug into this sum, which would be f of 2. Sorry, f of 1. F of 1 plus f of 2 plus f of 3 plus dot dot dot, and the last one would be f of n. What are the two common portions in the two brackets? From f of 2, I'm messing this thing up. This should have been here. This should have been, the second to last term is f of n. And the last term f of n plus 1. So f of 2 all the way down to f of n is common in both sets of brackets. F of 2 all the way down to f of n. The sum from r equal 1 to n, or 1 upon r into r plus 1 into r plus 2, now looks like a half into f of n plus 1. That's left in the first bracket, minus f of 1. Now, all I have to do is go back to the f of r function. Let me write what's f of r. F of r was r into r plus 1. F of r was 1 upon r into r plus 1. So if I wanted f of n plus 1, you simply replace n plus 1 wherever you see r. 1 upon n plus 1 into n plus 2. And f of 1, this guy, would be equal to 1 upon 1 times 2. And therefore the sum from r equal 1 to n, or 1 upon r into r plus 1 into r plus 2, is equal to a half into f of n plus 1, 1 upon n plus 1 into n plus 2, minus f of 1, which is a half. I'll leave the simplification for you. Y'all are up at sixes. All right. Should I add one more problem? Yes. Let me add one more problem. Let's look at number 7 from the same worksheet. Number 7. They said to us that f of r is equal to 1 upon r squared, is it? 1 upon r squared. You were given that, and you're asked to simplify. So given this, simplify f of r minus f of r plus 1. Okay, well, if that's f of r plus 1 has to be 1 upon r plus 1 all squared, and therefore f of r minus f of r plus 1 is equal to the expression for f of r, 1 upon r squared, minus the expression for f of r plus 1, 1 upon r plus 1 all squared. If I were to simplify that, the common LCM would be r squared into r plus 1 all squared. R plus 1 all squared. So on top I'll have r plus 1 all squared minus r squared. F of r minus f of r plus 1 can now be written as, if you open up your numerator and simplify, the r squared will cancel out. What's left on top? 2r plus 1. In my denominator I have r squared into r plus 1 all squared. So that takes care of the first part of the problem. Next part of the problem is saying, hence, find the sum of the first n terms of the series. Find the sum of the first n terms of the series 3 upon 1 squared plus 2 squared. 1 squared times 2 squared plus 5 upon 2 squared plus 3 squared. 2 squared times 3 squared. What's wrong with me? Plus 7 upon 3 squared times 4 squared. Find the sum of the first n terms of that series. Well, if you look at that series and compare it with this expression above here, if you were to plug in r equal 1 into this expression, in the numerator you'll have 3, and then in the denominator you have 1 squared times 2 squared. If you plug in r equal 2, in the numerator you have 2 to the 4 and 1, 5 upon 2 squared plus 2 squared times 3 squared. And let's just try the next one. R equal 3, 2, 3, 6 and 1, 7 upon 3 squared times 4 squared. So it would appear as if this guy is the general term for this series. So what's the magic? If I can therefore write the sum of the first n terms of this as the sum from r equal 1 to n of 2r plus 1 upon r squared into r plus 1 squared. Right, and as we just explained, if you were to start plugging in the different values of r into this expression, you're going to get this series above here. So this represents the first n terms of this guy. However, summing this is equivalent to summing the left-hand side of the same expression. Summing this is the same as summing that. So this gives me the sum from r equal 1 to n of f of r minus the sum from r equal 1 to n of f of r plus 1. Right? Obviously you're using your laws of summation there. And the sum from r equal 1 to n of 2r plus 1 upon r squared into r plus 1 all squared is equal to, write out the first few terms for f of r, and I'll get f of 1 plus f of 2 plus f of 3 plus ellipses, and the last one will be f of n minus, in the second summation it will be f of 2 plus f of 3 plus second to last one will be f of n, and the last one will be f of n plus 1. If you take the difference between these two guys, you end up with the sum from r equal 1 to n of 2r plus 1 upon r squared into r plus 1 squared, giving me, from the first bracket I have f of 1 left over, and from the last bracket minus f of n plus 1. And everybody knows what f of n is. Sorry, f of r is. F of r is 1 upon r squared. Where f of r is 1 upon r squared. Therefore, f of 1 will be 1 upon 1 squared. And f of n plus 1 will be 1 upon n plus 1 squared. Finally, I can write the sum from r equal 1 to n of 2r plus 1 upon r squared into r plus 1 all squared is equal to f of 1. F of 1 ends up being 1 minus 1 upon n plus 1 all squared. How you like them apples? Okay, I'm going to stop this tutorial here. The next tutorial I'm going to make is I'm going to start working on sequences. We had a little bit of that before, where we talked about sequences based on recurrence relations and sequences based on non-recurrence relations. So that will be the next tutorial. All right, we out. Again,